Hello everyone, and welcome back to an exciting day of logarithms. So solve this equation, or in other words solve for x. The first thing to do is notice that this is the addition of two logarithms. So on the left side I could create this as one logarithm as long as you multiply the 2x plus 1 with the x minus 4. And for now the 2 can just sit there and wait. The next step is get rid of the logarithm. So I do that, I remember that visually, especially if I have an orange pen. So the 3 is the base, and you raise that to a 2, and that will eliminate the logarithm. So on the right side, it's going to be, hold on, I miswrote that. The 3 is the base, and then it's raised to the 2, or in other words, that's a 9 on the right side. And on the left side, I might as well go ahead and multiply it out. So there's going to be 2x times x is 2x squared. And by doing that orange part, that actually eliminates the logarithm. So all that's left is a 2x squared, and then a 2x times negative 4 is negative 8x. And then distribute the 1. So that's just going to give us an x positive minus a 4. And we're most likely going to need to factor or use quadratic formulas, so I'll need to put everything on one side. On the right side, 3 squared is 9, so to eliminate that, subtract 9 from both sides. These cancel, leaving just a 0 on the right side. And on the left side, we have 2x squared. And as far as the x's, that's going to be negative 7x and then minus 13. And I don't know, maybe this could be factored, but if I spend time factoring it and it can't be factored, I'm going to have to use quadratic formula. So I might as well just skip to quadratic formula because it always works. So first of all, there's negative of the b, so negative of negative 7 plus or minus the square root. And then the negative 7 gets squared minus 4 times the a, which is 2, the c, which is negative 13. And then the whole thing is divided by 2 times a, or 2 times 2. And the next thing that I like to do is figure out what's inside of this square root. And it helps to have like an orange pen to do that. So negative 7 squared is 49. And then negative means we're going to have positive an 8 times a 13. So what is an 8 times a 13? The calculator on the side says that is 104. So whatever 49 plus 104 is, I believe that's 153, that is what's inside the radical. So on the 7, it will become positive. And then let me just make sure, 104 with 49, that's going to be a 13, that's a 5. So inside the radical is a 153. And it's divided by 4. So then I need to see how much this equals using the good old calculator. Erase this other stuff. So I'm going to put the numerator in parentheses, 7 plus the square root of 153, and then that gets divided by 4. So the whole thing is in parentheses, and then it gets divided by 4. So 4.842 is a possible answer. And then if I redo it with the minus, I get negative 1.342. All right, go back to the work. And I got two answers. X equals a 4.842. X equals negative 1.342. But there's a little mouse in my brain saying you can't take log of a negative. So maybe I should throw this answer out. Let's see. If x was a negative 1.3, then this would be a negative 1.3, whatever it was, 42, minus a 4 inside of the logarithm, so that would be negative. So that answer is out. So we just get the positive answer. And then of course I do want to graph it and see, does that seem like it's correct? So I'm gonna switch back over to the calculator and see if my answer seems correct. So graph it, go to y equals, erase this old problem, and it had log base 3. My calculator doesn't have log base 3, so what I can do is take log of the 2x plus 1 and then divide by log of 3. So that compensates for the base being 3. And then it said plus log of x minus 4. And again, this needs to be divided by log of 3 to compensate for its base being 3. And then it said, when is that going to equal a 2? And the positive answer that I got was a 4.842. So take a look at the graph and see, I need to zoom way in. There we go. All right, there is, finally getting zoomed in enough. There is where they intersect, and for some reason the pixels are not cooperating. Okay, that's weird. All right, what I'm gonna do is go back and reset the window and have it go from -10 to 10 and -10 to 10. How about that? Well, that's close. I don't know what's going on with the pixels right now, because right there I can see it, but when I let go of the screen, ready, 1, 2, 3, it disappears. Okay, sorry. Now we're getting there. So that intersection, so let me try to get to where they intersect. There we go. So it says that they intersect at x equals 4.842 in the upper left-hand corner. So it took a little bit of work to verify, but that was correct. So then I can go back to my answer, and because I did extra work, I'm going to double box this answer. It's worth a double box and even some shading. All right, that's it.